Okay, welcome everybody to Verkle Implementers Call number 9. We will jump right into the agenda, starting off with client team updates. Would anyone like to kick things off?
I guess yeah, I'll go ahead. Yeah, so for me at least, we've been working on the shadow fork, and yeah, so there's been some progress. We now can simulate a shadow fork in kurtosis. Um, and yeah, so we start with a MPT state. We let TX run for a while until we have a big enough state, and then we trigger the transition. So that's working. And then we started using. Okay, sorry, I see a message from Pari. Not fully in kurtosis. I'm not sure what we. Oh, it's using Ansible. But wait, I run it on my own machine, so it's got to be it's got to be in kurtosis somehow.
But that was just the simulated version where for the first bug we found, where you just had a multi-block transition.
Okay, understood. But yeah, so okay, right. So it's not fully kurtosis. Okay, gotcha. But yeah, anyway, we have a demonstrator, and so we could build a testnet like this. But of course, the more interesting approach is to start a shadow fork. So we attempted Holiski, and because it's a real payload, we started finding bugs that were not visible before. So yeah, it was just about basically saving pointers and restoring them. It's a bit finicky, but we're. I mean, I think we're making progress, although we're not, it's not done yet. And otherwise, I also looked into the testing. I don't know if Dan's here. Maybe we'll talk about it at the end. So I created an equivalent of a subcommand for EVM transaction, so that they can stimulate transactions and see what the output tree is. But yeah, there were some misunderstandings. So yeah, I'll fix that after my holiday because I'm currently on holiday. But yeah, I'm hoping to have some better, like, nicer announcements to make in a couple of weeks time. Yeah, Ignacio, did you have anything else? Yeah, there was a test vector. Is there anything else you worked on?
No. I will share again in the chat something that I shared in Discord if somebody wants to take a look at it. Yeah, it's there. I just completed some test vectors for cryptography libraries, covering some corner cases in crypto implementations. I already ran these things in the Go implementation. I know that people from the NIM team is including them in the NIM implementation. Probably we will work on the Rust implementation in the near future. So yeah, and probably in January I will complete the other part of the test vectors regarding the Verkle tree data structure to cover some interesting corner cases there, and witness generation, which also has some interesting corner cases. That's just that.
I can give some update regarding Ethereum JS stateless sync effort that is going on. And for that, basically, I was integrating the new gas schedule, basically adding the charges for Verkle access, Verkle witness accesses, and so I have had some limited success on that front. That we are able to we are able to run few of the transactions, and I've aimed to basically complete this in this week, and maybe then we can again try syncing constant into with Ethereum JS stateless. And I have few queries regarding this, Guillaume, and I have sort of dropped them in the testnet. I think you haven't seen them yet.
That's right. I haven't. I'll have a look. Sorry about that.
I can give an update regarding Bezu. So we are still working in order to have the same root hash for the Genesis block. So we fixed several issues. The last issues, it seems that it's a difference between the specification and the current implementation in Guest. So I'm waiting for your feedback, Guillaume. It's not urgent, but it seems that for the specification, in order to have the main storage offset, we want to use the PO operation, and in Guess it was a shift left. So in order to have the same route, we are doing as Guess, we are doing a shift left, but we need to know in the future if we want to.
It's the next item on the agenda.
Yeah, okay. Okay, so I will let you talk about that. But after this modification, we have the same root node. So we still have a last operation in order to have the same state root hash. But clearly we are close. We are close to have the same general state root. And when we'll have that, we'll try to join the testnet in order to import more block. I still have to do some refactor on my side, but it's not something that will prevent us to try to join the testnet. So yeah, it's all on my side.
I can go and share updates for Aragon. So I have been able to join the network per se, but I'm facing issues on block number 12. So I think it has something to do with gas schedule mismatch. So I'm working and looking into what sort of mismatch that might be. Although I sort of implemented the gas schedule changes, but I hope to resolve this issue and make further progress with Verkle Gen DevNet 2. That's all from Aragon.
Sorry, quick question. Didn't someone else not have a problem with block 12?
Yeah, we did with Ethereum JS. But I think block 12 is the first block that contains other things than just like simple value, each value transfers. So it makes sense that, you know, people would block on that, right?
Okay. Yeah. Well, if you're having questions on that, just just message us.
Will do, sure.
I think I'll go next. On the Nethermind side, I don't have any significant updates. There are some issues with block production, and I'm just trying to get that fixed. After that, we will get back on syncing using Verkle Sync.
Okay, so I can speak for Nimbus team. Not much progress lately. Lots of end of the year vacations. We're finalizing our mat library, and we will integrate it into our Verkle implementation in the next couple of weeks, apparently, and then we can finally start seeing root hashes. But then we're still a bit further away to join the testnet talk.
Okay. Anyone else? Cool. We can move on then. The next agenda topic is Guillaume with the main storage offset value fix.
Right. So, like, I mean, Karim already described the issue pretty well. Let me look for my window. Here we go. So there was a mistake in the I don't know if you guys can see my screen. Yeah. So there was a mistake in the computation of the main storage offset value. It was supposed to be a power, and we were instead using some shift, some incorrect shift. So Karim pointed out that this was incorrect. This is my fix. I would need, before I merge it, to confirm, because what was maybe a bit surprising to me at first was that Tanish didn't find it, or Ethereum.js didn't find it. But then if your reference was my repo, clearly you also have the mistake. So before I merge it and confirm that that this is incorrect, I wanted people from Ethereum.js and Nethermind to have a look and confirm that this is a bug. I mean, I expect them to confirm that, but just want to make sure. And when this is done, I mean, we're not going to relaunch the testnet just for that. It's just a value. It's just an offset. But when we do relaunch, it would make sense to have it fixed, to have the fix in. I don't know if you guys have some comments. That's also what I was thinking. Maybe the block 12 is related, but then because G11 or Gajender went and Gabriel passed this issue, I guess they must have somehow either made the same mistake, or it's not related to this.
I think we have made the same mistake.
Okay. So yeah, if you could just confirm, look at the spec, look at your code again, confirm that this is incorrect on your code, in your code as well, and then get back to me. I'll merge that fix, and we'll be ready for relaunch, basically. Oh, and I'm also going to copy the link into the chat so that you have the reference. But yeah, that's pretty much it on this topic, if everybody agrees.
Cool. Thank you. Next up, we have on the agenda the curve discussion. I believe, Carlos, if I heard correctly from Guillaume, you will give a quick update or summary on some discussion that recently happened around curve choice in Verkle.
Yeah, no changes so far, so nothing to be worried about. But I kind of did a bit of exploration based on Antonio's latest paper, which is exactly about deriving VLS curves and curves embedded into those. And basically, the only thing that I was trying to see if what was easy to sort out is the fact that we currently need to split the EVM stored value into 128 limbs to then commit to both limbs instead of a single one of 256 bits. That's because of Bandersnatch field size, well, BLS 12381 field size indeed, which is 253 bits instead of 256. So we cannot fit everything into it. The proposal was basically trying to find if it was worth it to find a new pair of curves such that we can get rid of this extra commitment or MSM term, plus not lose, I think it's 1 or 2 bits of information for every single value that we store. So far, the feedback was given from Antonio Dankrat and Gottfried, that I recall at least, also Ignacio, if I remember correctly. The most important things mentioned were the extra MSM term shouldn't be a performance or space issue. This is from Antonio Dankrat. Same with basically the design of a new VLS curve isn't worth the deal, considering all of the work that it would take to actually put this into a precompile and design everything and all that stuff. Third, BLS 12381 is also probably going to make it into mainnet anyways via 4844. So it's probably worth it to like reuse this anyways and like hack a little bit the way in which we commit to the storage values by having these two limbs. And finally, this is the one I don't really understand. It was mentioned that the scalar field bigger than 256 bits might not be a good thing performance-wise. But this is only one extra bit, and we only use the scalar field, if I remember correctly, for the MSMs. So this only affects in having one more iteration of double and add, which shouldn't be, at least to my perspective, an issue performance-wise. But in any case, this was all of the feedback that Antonio and Dankrat gave, and as Antonio and Gottfried agreed on points 2 and 3, and I do agree too. So far it seems that, as was already presented, BLS 381 plus Van der Wagen and the splitting value looks like the most precise technique, or the best one that we can aim for so far. So that should be it.
Awesome. Thank you, Carlos. Does anyone have anything to add to that or any questions?
Yeah. I mean, just a quick comment. I mean, yeah, the extra bit would not be a problem in my view, because we could always shuffle it somewhere. I mean, this is what we do, but it would have the same. It could have the same complexity because we have an extra bit hanging around. Yeah, I think it's still interesting to dig, but if it makes no sense to, I mean, if it's not worth the effort, then yeah, we'll continue with the current model. It's just that there was an opportunity to maybe make things a bit simpler for circuits, but yeah, I mean, I was trying to answer the question you put on the chat, Josh.
Got it. Thank you. Okay. Next up on the agenda item is agenda item 4, gas schedule, and perhaps reviewing it as initially EIP 4762 was created with the idea that the gas schedule would be adopted in the fork before Verkle trees, and that does not seem likely anymore. I think, maybe you had some thoughts that you would like to start with here, possibly?
Yeah, so it's really an open discussion. Dankrat was going to say something already. Go ahead. No, okay.
Sorry, me? Yeah, so I thought we talked about this before and decided that it didn't really make sense because we had the ideas of lowering gas for certain operations because of Verkle, but we can't really do that before we implemented Verkle, right? That's my memories of this discussion last time.
Mm-hmm. Yeah, exactly. So, but the problem now is that we have this when all the tooling breaks. Basically, we have TX fuzz, we have other, like for example, Adrien from Open Zeppelin started deploying some of his test contracts on the test net, and all the tooling breaks because we pay for each transaction. You have the intrinsic gas, which is 21,000 gas that you pay upfront. And my understanding, at least, of this, the reason for this intrinsic gas is to cover all the costs that you would do, incur to kickstart a transaction. And one of them is, of course, to go get the account from the database, the sending account from the database, and yeah, this is something that we pay on the side. We pay for on the side now because we pay the cost of adding it to the witness. So that means that even sending a simple transaction is no longer 21,000 gas. It becomes something around 36,000. I forgot the exact number, 34,000. But a lot of tooling gets broken because that value is simply hard-coded, including TX fuzz, but also, like I said, some Open Zeppelin tooling. And I assume this is just the surface. There's got to be 1,000 other tools that have this value hard-coded. So my question is, maybe we should revisit at least the intrinsic gas and potentially other costs that we should update during the Verkle transition, because it feels like you're paying double, really. It doesn't feel fair that if the intrinsic gas cost covers the reading of the sender account, the user should pay on top of that for the witness cost. So yeah, that's basically the case for it. So maybe reduce the intrinsic gas from 21,000 to 21,000 minus the cost of accessing one account, at least one account, if not the sender account and the recipient account. But yeah, I don't know if there's some counter proposal to this, or if it is expected that the cost will be higher.
I mean, I think that makes sense. What does it do? It's like really accessing two accounts. What would that cost in isolation? It's just like, it's much less than 21,000, right?
Yes. It's, I mean, I would have to do the calculation, but it is much less than 21,000 for sure. Although, when you add it,
you could simply say the 21,000 already includes the cost of accessing the sender and the target account.
Right. So my question would then be, do we keep the 21,000 and so make the sender and target account free, I mean, seemingly free, so we don't charge the Verkle cost for this, or do we change the intrinsic gas to make it 21,000 minus the cost, so that when you actually charge the cost, it becomes like you find 21,000 again.
I mean, I think it's very clearly better to do the first one, because otherwise, let's say later we decide, oh, we want to change the gas cost, or a roll-up wants to have a different gas schedule, they would have to do this like rebalancing to make sure this is 21,000 or less. So if the goal is the base transaction should cost 21,000, then I think the answer is very clear.
Yeah. Okay. Yeah, then that's fair enough. I mean, if anybody else has an opinion, but I think that's also the best approach. Okay.
I think what we can do is basically in 21,000 we can basically give few accesses with the origin and the destination accesses free. So basically when we charge 21,000, we basically add those accesses anyway to our accounting, and then maybe we don't really need to.
Yeah. I think this is exactly what we agreed on. I'm not sure. Maybe I misunderstand your point, Gijinder. I think
okay. I'm fine. I mean, maybe I didn't understand a bit the discussion here.
Right. So let me summarize. Maybe I'm the one who did not understand. Instead of, we keep the 21,000 value, so we don't change that. But in the code, like when at least I visualize it in Geth. When you start up your transaction, you say, okay, this is you're going to read the sender account, you're going to read the recipient account. Those values don't get charged, basically. This in this specific context, those values are free. Well, seemingly free. They're included in the 21,000, and then we just charge the regular. But and then we still add those values to the witness so that they don't get charged later on. And that's that's basically it.
Yeah, then we are on the same page.
Okay. If nothing else on this topic.
Yes, just one point. I will therefore make create a PR to update the EIP, and I will share it on the channel, on the Discord R&D channel for more feedback.
Sounds good. Cool. Last up, we have a topic that we've discussed on a recent call, the Verkle verification precompile. I think, Guillaume, again, you had a few things that you wanted to touch on here.
Yeah, we didn't really have time to update, to mention it last time, but so there's been a proposal. Let me share my screen again here. So the idea would be to add a precompile that does state verification. So it should no longer be called the Verkle proof verification precompile, because it's actually the state proof verification precompile. Because Proto Lambda swooped in and gave some feedback and said it would be great to have also the ability to verify Merkle trees. So the principle of this precompile is like the way it works is very simple. You just pass a series of bytes, and the first byte is a version, which is currently 1 byte. We can make it larger if you think we'll have so many proof systems in the future that it warrants more than 1 byte. Then you have the state root, which is taken from the block, and then the proof data, which is really just I mean, it's an arbitrary payload that depends on the proof type. And then what the precompile does, it gets the version from the first byte, and if version is 0, it will get an MPT. It will deserialize the MPT multiproof and verify it, called the MPT verification function. If version is 1, it will deserialize a Verkle proof, and maybe those functions should actually be called something else, or at least have a different name, and then called the polynomial commitment scheme multiproof verification thing. And it's in its current description, the precompile returns 1 if it successfully verified the proof, and 0 if it did not verify the proof successfully. Another feedback that was given by Proto was that the precompile should revert, period. I'm not sure there's, I mean, okay, according to him, it saves a bit of gas, so we could do that. I'm honestly not having any opinion on this. I think it's a bit simpler to describe that. So this is to describe just returning a value, but I don't mind reverting if that's what people prefer. And then Ignacio had some extra comments about it, which if you want to give them, Ignacio.
Yeah, I had 2 comments regarding this topic. The first one is that some weeks ago I was reading this and realized that I think this API is missing something else. So the API today is that you give the proof, the serialized proof, and the state root, and you will get a yes or no if that verifies. But I believe that this precompile also needs to have a way to check which keys are being proven in this proof. Because from, like, if you're a contract and you are calling and you are receiving a proof, and you will use this precompile to verify the proof, you will be interested in knowing which keys are being verified, because if you don't know that, you are not actually sure what is being proven. So yeah, that's one point. And the other point is the support from the Markov-Patricia tree proof verification. My concern about this is if this is like worth it, because I know if in a year or a year and a half or something like that, Verkle trees will be used in mainnet. I don't know if many people will still be using Markov-Patricia tree proofs for things. And also the CG EVM will have to include implementation of the proof verification. So that's kind of some extra complexity that we are pushing there. But maybe Carlos has a better idea if that's a huge pain or not, or because, yeah, maybe in the future we can remove the support for version 0, which is this Markov-Patricia tree, but that's kind of a breaking change, and I don't know if that's kind of nice. So yeah, those were my 2 points. Yes, Carlos.
Yeah, I think there's better ways to go with this. I think we started briefly discussing it with Guillaume, and I think you, Ignacio, also, after talking with Jordi, that, for instance, you can do proof of equivalence for trees and stuff like that, and you can like have external services, and you can even have yourself this kind of thing, so that you don't need to load the entire mainnet to be able to support this kind of protocol when the usage might already be low, but even lower when we switch to Verkle. Because I agree, there's not many reasons why you would like to use MPT rather than Verkle trees directly. So I'm with you.
Yeah, so one question I didn't understand, like one point I didn't understand from what you said, Carlos. Yes, it's true. We have this possibility of having proof of equivalence, but like, okay, what I mean is we have, even if it stops in a year, if people don't use this precompile after, sorry, the MPT part of the precompile after a year, there will still be deployed contracts that could potentially use it to verify a proof at any moment. So that would break those use cases, and it would still be useful. Now the point I didn't really get from the point you made, Carlos, is it really much more complicated to implement this precompile? Because this is not the impression I got, but I'm not really versed into the ZKVM.
I wouldn't say complicated as to like just support it mainly. The complex thing will basically be all of the logistics if then this gets deprecated, or the space that it might take, or the maintenance / burden on reviewing, auditing, etc. If then almost no one is actually using it, which is kind of the same thing that happens with RipMD or Blake 2F or stuff like that. That almost sees no usage, yet everyone needs to pay the cost of supporting it.
Yeah, and indeed, I mean, that's basically the other side of the argument I was making, which is indeed we would still need to support it like we support RipMD or other precompiles that we really no one uses. But in the off chance that they could be used, we have to be able to support them. The other point about this isn't really going to be a year, because all those all those rollups, some of them are presumably not going to switch to Verkle at the exact same time that that mainnet switches to Verkle. So if it takes them another a further 6 months, I would say my argument doesn't hold. But if, for example, I think we had a talk with Scroll, they were not super eager to jump on the Verkle bandwagon. So if those if those people decide, or people like them, I mean, decide not to switch for more years, a non-insignificant number of years, it would make complete sense to keep it. So I guess one thing we need to do is talk to every rollup and figure out what their plans, and I mean mostly the optimistic rollups, to figure out what their plans are regarding Verkle. But yep, sorry, go ahead.
Oh, I mean, it's not obvious that a rollup having a different state scheme should impact what we should implement on an L1. Like, for example, rollups might just use completely incompatible schemes that we're never going to implement natively in our precompile. So I think like it's worth thinking through what is the exact advantage of, say, L1 being able to verify a rollup state proof. There may be applications, but I don't know if it's been properly investigated, if that's necessary.
I think
And other ways that could be universal.
Like there are applications, but I agree with you that if they want to support those applications, they should be the ones that try to be compatible with L1 rather than the opposite way around. So I agree. But you can swap the roots of the trees to like make calls that interact with data from L1 being in L2 or vice versa. So there's definitely applications for that. But yeah, I'm with you also on this one.
Right. Okay. Yeah, that's a good point. Just also jumping back to what you said about the equivalence. So, for example, a ZK rollup would have no problem, and indeed, like if a ZK rollup maintains the equivalence between two trees, then all they need is because they have the proof of the equivalence, all they need is to have the Verkle proof part of the precompile. But what about non-ZK rollups? Yeah, like for example, optimistic rollups, would they need to also maintain an equivalence on their own to be able to use it this way?
I don't think what you say makes sense, because the whole reason someone uses a different scheme, for example, for ZK rollup, is that they don't want to, like, it's too complex for them to use Merkle or Verkle or whatever, so they want to use their own. And so equivalence completely gets rid of that advantage. Like then they might as well just use Verkle only.
Well, okay. I think the problem is, I mean, from what I understand, at least Optimism does use the same scheme, like the same MPT scheme. So if they don't want to switch to Verkle immediately, we are exactly in that use case I described, where we have a major player that still uses the old system that is compatible with the current version of mainnet, but will no longer be in the future.
I would ask the question like, how is Optimism working now without this precompile? It's like, is this something critical for them? Is they are having some other workaround today?
That's a good question. I mean, they are really eager to push for it, so I assume that it's basically that yes, they have a workaround, but it's costing them a lot of gas. Okay, well, I guess when just to progress at least on this point, is figure out if indeed it is a problem, because if it is a problem, what I described is really a problem that people won't switch, because if Optimism switches and other optimistic rollups like Arbitrum, like the major ones, decide to move on at the same time or close enough, yeah, it would not make sense to support it. I agree. The other point I wanted to discuss, or at least get a clarification on, Ignacio, is when you said you need to pass the keys. But I do not remember that was the point you initially made, because if you pass the witness, you do pass the keys, right? Like if you pass something that is exactly like what we pass in a block, we also declare the keys that we want to prove. So maybe I mean I don't think I understood your point. Like why is that? Why is passing the key important? Like via the API?
I can clarify. Yes, I mean the keys are part of the proof, but my point is that the contract wants to know which keys and values are being proven by this proof. So, for example, if you are a contract that what you want to know if is like which is my balance at a particular block number, what you would expect to receive is a proof of that. So you will receive this proof blob and the state root, and you will use the precompile, and you will get yes, this proof is correct. But if you don't do anything else, if you don't check that this witness includes the keys of my wallet address with the value that you want to verify is true, then the only thing that you know is that the proof is correct, but you don't really know which is being proven if you don't have a way to also tell the precompile, hey, is this witness including these keys and values in the proof or not? Because I can send a proof of your balance and not my balance, and you don't have a way to know that if you don't have a way to tell the precompile to also check if some particular keys and values are part of the witness.
Right.
You know, if that's clear.
Yeah, because indeed you receive an opaque payload, and you don't know if your key is really in the witness unless you implement some logic yourself, and therefore it kind of beats the point of using this precompile. I mean, it's I think there are use cases where you don't need this, but it's true there are potential use cases in which you do need this. Yeah. Okay, no, that's fair enough.
I mean, I would argue you want even more. Ideally, you want even logically to say what you want to access. So that's not even, because even if you prove key values, then the proof is still dependent on the mapping of like where, let's say where you store the balance. Ideally, for like a really independent proof scheme, you would just say like account balance is this.
Yeah, I agree with that.
Okay, so that's a huge change to the interface, but yeah, okay, no, that makes sense. I would, yeah, I need to think about it, how to implement the API, but okay, yeah, that can be done, I guess.
Okay, cool. We have made it through the agenda. Anyone else have anything they would like to bring up? If
I
not,
think there is an extra point in the agenda, number 6.
yes, the testing doc that was created by Dan. So we could touch on this. I was thinking that I was DMing with Dan before the call, and just now, actually, I don't think he's on the call. He couldn't make it. That maybe it's best to wait for Dan or anyone else from the testing team to be on the call to discuss. It's linked in the notes if anyone would like to review the doc. I'll link it again here. 1 second, but yes, I think that will wait for a future call. Sounds good to you and everybody. Cool. Okay. Milos, yes. Oh, yeah. Sorry, Milos. I forgot that you had brought up a few things. Please go ahead.
Yeah, basically, I posted a question on the agenda as well. It's about the state and how the nodes are encoded, and if there is some standard way, and whether we should standardize some way. Like, for example, I'm not sure exactly how we currently store what are the nodes and the values, or we actually just store the commitments of them in the block itself, or just in general, like, should we standardize this in some way? I agree that clients can do however they want implementation, but maybe there should be, or should we think about standardizing? And also, did we calculate the impact on the archive nodes, whether the Verkle would actually be more helpful or not compared to the Verkle? And the reason for that is, if we have a node that has, like, I don't know, a bunch of values, but only one change per block, then every new version of that node would basically just duplicate the entire node itself. And with just one version, one value change, one child change, would that, like, increase the value that is used, or how, like, did we do any analysis on that?
Did you see my answer in the channel? Because I did respond to you. I mean, I can give you the summary, the gist. So no, there's no standardization, and that wasn't part of my answer on the channel, but I don't think there should be, simply because even in the MPT space, there's a lot of design iterations going on right now. So it would be I don't think it's a good idea to standardize right now when everything is still evolving quite fast. When it comes to the archive node, or at least size estimates, I responded to you. I gave an estimate. We do not have, like I said, I was saying at the beginning, we are currently working on the shadow fork of Holesky, so we can give more accurate data then. But the estimate, without all the optimization that you mentioned and those we have in mind, we save basically 10% of the space. Like this is the back of the envelope calculation, so it could completely go wrong. Once again, we need a real payload to give you some actual number, an actual explainable number. But from what I can tell, yeah, it should be much smaller because we don't store as many data. But we also have the problem that currently we don't have any specific. I'm talking for Geth here, at least. We don't have any specific optimization when you have when you recognize a pattern, for example, an account. You could store that in a much smaller way, but we don't have this optimization. So I would say currently the amount of gain is limited, because storing an account is basically 5 times as large as the way you could store it. But that's connecting back to my first point, that we still have a very large design space that we're currently discovering or going around. So it's not a good time to standardize, in my opinion.
Okay, thanks.
But let me return the question then, if I may. What would be your needs for that? Why do you ask for standardization? Like, is there a reason behind it, or is it just because because, yeah, for example, you have is it out of curiosity, or is there an intent behind that?
Yes, I was basically just looking in the portal network case of how much, let's say, data would a node need to store, and how much data when the node transmits the portal network nodes transmit the Verkle nodes between themselves, how much payload would that be and stuff like that, and realized that for a big node, that's 8 kilobytes, which is like for the branches that are full. That's significantly bigger than what is the case with the Merkle tree, but it shouldn't be the problem. And I was looking like if there is a way to standardize. Of course, we can create a standard within the portal network, but I was considering if there's maybe already some standard that is used that I just wasn't aware of. But yeah, we can make a standard for us when we transmit like a smaller nodes, and also like the way we would store them as well, etc. But I was just curious if there is a standard. And yeah, and I was looking for the archive state because I was basically the portal network, if we support historical state and everything, it would also maybe affect us in a way, and I wanted to know if there was some estimate down in that space. So basically, I was just looking how it connects with the needs and usage in the portal network case.
Yeah, when it comes to archive node, I'd say let's wait for what Somnat, like for Somnat's work to complete, because I'm sure we can get some very accurate data. But yeah, I just wanted to go back to one point you made. No node stored in the database is 8 kilobytes, right? We only store by path. I mean, I'm talking about Geth here. We only store by path. So when we give an internal node, we only give its commitment because its children are known by the path. So you should never find yourself in a position of sending an 8 kilobyte node around the network. I mean, I'm saying you should never, you shouldn't have to, basically. Yeah, so I don't know if that helps, but this is clearly not a standard. I'm just saying you don't have to worry, or at least you should not have to worry about sending an 8 kilobyte node across the network.
I mean, okay, I will have to think if that's something that we can use in the portal network case as well, because you don't have, like you as a one client in the network, you don't see the entire tree, you don't know the entire tree. So you need to find that through the network itself, but it's hard to know because we cannot store the, like, where would you get the information? How do you get to the leaf node that actually contains the data? But yeah.
I mean, if I understand your question correctly, which I might not, how do you know that? Well, you find yeah, but you need to connect to the parent. Yeah, okay. Yeah, maybe what I said doesn't apply to you. I would have to think it over.
Okay, thanks.
Okay. Well, thank you everyone for joining, and we will resume the call next year in January. Talk to you soon.
Thanks.
All right, guys.
Have a nice holiday.
Thank you. Happy holidays.
Bye.
Happy holidays.
Bye.